Hello, and welcome to yet another tutorial. This time around we're going to do some acoustic simulations using Pachyderm, I don't know how to call it, a plugin for Rhino and Grasshopper. So first of all, about the plugin, you can just get it from foodforrhino.com, and I don't have it open, but it is going to be there, right? So it is, let me just write it here for you, foodforrhino.com. That plugin, Pachyderm, Pachyderm, Pachyderm. That plugin has a installer rather than, you don't install it in a typical way, or actually you do install it in a typical way. It's just that all other plugins in Grasshopper are not installed in a typical way. But it is an executable file. It is an installer, which means you just double click on it, will run the installing process, and you'll have it, right? So Pachyderm can be run in Rhino. If you just type in, once you've installed it, and you type in Pachyderm, you can see some of the tools here listed. But we will be using it in Grasshopper because why not, right? In Grasshopper, it's a little bit more custom. Let's say it like that. You can mess around with more things in Grasshopper and kind of roll back the animations a little bit easier. And change things up a little bit easier as well. So next up, what kind of setup do I have? Well, the first super important thing is that I'm using meters, not millimeters, but meters. So what I've done is I've exported my panels, which are located right here, and yeah, they're just there. I've exported my panels, or rather a single panel, into a new file. I've opened it up and I just arrayed it. And this is just me talking, so let me just grab a clipping plane, move it up so that you can see at least how the panels are arranged in the room. So this box right here is just a box, right? It represents a room. These panels represent panels that are going to be in the room, and the point right here represents the speaker, right? A point from which sound waves are being generated. So in total I have 24 on both sides, so 48 copies of my panels. I have a single box and a single point. Right? That's my whole setup, and I am using meters rather than millimeters. That's very important for simulation purposes, right? So you need to scale everything down to be correct size in meters. If you don't know how to change the units in your file, you just type in units, hit enter, and here you just change it to meters, right? Please don't change your robot cutting or simulation file into meters. Keep it at millimeters. It's just for this particular work that you need to do it. For this particular simulation, sorry, that you need to do it. One last thing before we move into Grasshopper is Pachyderm works with closed poly surfaces. So it needs to be a closed geometry, meaning you can't have exploded shapes, and it does need to be a poly surface geometry. At least I think so. I might be wrong about that one. But yeah, that's basically how it goes. A bunch of panels, box, and a point inside of the box, anywhere. The room size that I'm using is 6 meters by 5.5 meters by 3 meters, right? So it's not a big room, but it will be good enough. So that's our setup. All right. Now in Grasshopper, I assume you already have Pachyderm installed. So in Grasshopper, this is the definition that we're going to do. So it's going to be a really small one. And I'm just going to kind of guide you through it. So this is like my notes as per usual. So once you have installed that plugin, it's going to have an A letter. Yeah, there we go. Acoustics or whatever. Yeah, Acoustics. And this is the plugin itself, right? So there's a lot of things that you can get with this plugin. You can get reverberation times. You can get the how's it called? How much sound the walls eat up according to the frequency of sound. So do the walls eat up more of the high pitched noise, or do the walls eat up more of the low pitch sound? So you can get a lot of different things here. I am going to just show you the pure basics of it, right? And also something that's not an Excel spreadsheet, but rather a visual representation of the sound waves bouncing around in your room. Let's get started. So the main important component that we're going to use is under visualize. It's going to be called visualize pachyderm. I'll call it pachyderm. I know maybe it's not the correct way to pronounce it, but I'll just say pachyderm. Visualize pachyderm raise. That's the main one. I'm just going to plop it here and just see what it asks me to give it. It asks me for a room, right? Okay. It asks me for a source. Okay. So source of the sound. Directions of the from away from the source. So basically towards where are the vectors going, right? Then terminating surface, we don't really care about that. And then the last one, number of bounces. So how many times does the sound particle bounce around before it stops, right? Before it gets deleted. Okay, so room first, right? Here under computation, no, it's not here. Under model, I have either NURB scene or polygon scene. I have no idea. What's the difference? I mean, it seems like it's the same thing. So I will, I would assume this is a mesh, but when I give it a mesh, it just complains. So, and it likes when I give it a NURBS polysurface. So I'll just keep giving it a NURBS polysurface, I guess. So polygon scene, or yeah, polygon scene. That's going to be our room. Oops. That's going to be our room. And the question is what constitutes out of all of these elements, what constitutes it to be, what is a room out of all of these elements? Well, a room is everything except for that single point. Let me go to wireframe view. So a room is everything, this box, as well as these panels. They belong to a room, right? Except for this little point right here, because this is the source of the sound. So for room, Rhino geometry, Grasshopper geometry, yeah, we will just kind of reference it in as a brep or a series of breps, set multiple, like that. There we go. So it got referenced in, and I will just plug it into Grasshopper geometry, like that, right? So now it kind of works. And actually, before we kind of go full ham here, let me clear values, and I will just choose like 1 or 2 panels from here and the room itself. It's going to be too heavy to deal with all of the geometry set. So I'll just have like the box and 2 panels set for now. So only 3 breps in total. It's asking us if does the component obtain the geometry from rhinoceros model, and I'm gonna lie. I'm gonna say no. Right? I'm gonna say no and hope that it's going to be okay with it. The reason why I'm saying no is because if I said yes, then it would try to get material properties from the Rhino file, and I don't really want that. So I'm not gonna give it any. Then we have Grasshopper layers. So it's asking us what kind of layer should, wait, what kind of error do we get? Yeah, so it's asking us what layer, which layer from here should it use to determine the material, right? So what we're going to do, and actually let me double check this. Yeah, what we're going to do is for every BREP that we have, we will set the index of the layer to 0. That's because I have only one layer, and that's called default, and that is right at the top, so it means it's layer index 0, right? Easy enough. So first of all, if I just give it index 0 here, it's going to complain. It's going to say number of these objects needs to be the same as number of number of indices. So what I can do is I can take this number 0 and repeat it, repeat data, repeat it the amount of times as how many objects I have here in this BREP component. So I can just measure list length, because this is a list of geometry. List length is going to spit out number 3 for me, because right now I have only 3 elements referenced, the box and these 2 panels right here. So it's going to spit out number 3 for me, and basically the output of this is just going to be 0, 0, 0, right? 3 zeros. But if I give this component like 5 BREPs, then it's going to be 5 zeros here. So that's how it works. So I fed it in, and now this seems to be working. If this is complaining, then what you might need to do is you might need to go into Rhino, type in pachyderm acoustic, enter. It will open up this this box here, or menu here, where you'll go into materials and you'll choose your layer. So usually you just have one, so I'll just choose this layer right here, the layer in which your elements are together with the box itself. Default layer, and I'll just choose the material that I want these to have. So in this case, it will be plaster. That's it. We're done. I just click close. That was easy. Okay, so this is not complaining anymore. What's the last one? Voxel grid depth, number of voxels in each dimensions. I have no idea what you mean by this. Yeah, I mean, I understand what you mean by this, but why is this a thing? Let me check one thing. I know. Pretty crappy tutorial if I need. Oh, no, cancel. Yep. Let me pause the video and we will start anew. Okay, so guess what we're not gonna do? We're not gonna start exploring in the middle of a freaking tutorial. That is not a good idea. Polygon scene, that's all you need to know. Source objects. Okay, I'll come back to acoustics, there we go. And here under audio, I believe, no, under model, I will find geodesic source. Geodesic source right here, and I'll just plop it in like so. That's going to be our source, this little guy right here. It asks us for the origin, right? And we do have the origin. We have this little point here. So I'll reference it in, point, set one point. That's going to be our origin point. Then it's going to ask us for the power. How intense the sound is. So it's 120, I guess, decibels. I don't know, probably decibels. So 120 decibels, that's fine. And signal delay. That's also the way it's constructed. This is fine. We don't want any delay for the signal. So we want to start it immediately as we're going to start the simulation. Okay, so there's this kind of little guy here that's going to produce a bunch of sound waves, right? Next up, we have ray directions. So what kind of directions do we want these sound waves to take, right? In which direction should the sound waves go? And for this, you can do like a bunch of different things. The one that I used was, I believe it's from Pufferfish plugin. It's called Vector Star. Yeah, Vector Star. So this guy right here. Let me just check. Yes, it is in the Pufferfish plugin, so you can download Pufferfish from Food for Rhino as well. Foodforrhino.com, Pufferfish, and you will Pufferfish, and you will have this tool. So what it does, it creates a bunch of vectors according to, you know, like a spherical array of vectors is created with this tool. So we can say that our plane is our point, so that it starts from our point. Then it's going to ask us for how many divisions, how many steps of division should it take. So if we give it one step of divisions, you'll see that it creates twice as many points. So this is no steps, one step, right? If we give it 10 steps, this is how it's going to look like. And I think we can kind of do like 50 steps. Yeah, something like that, right? So in total, we end up having 15,608 vectors, right? Everything else, subdivision type and dimensionality, we keep it as default. So we have these vectors. The thing is that they are omnidirectional, meaning they go in all directions. I actually think that it's much more informative if we yell at one direction and see how it bounces back, right? So I'm going to only keep the vectors that are looking towards these panels. How do we do that? Well, we first need to deconstruct these vectors. Deconstruct vector into their XYZ coordinates. Once that is done, we will know, like from these coordinates, we will know which vectors are looking in, so this is X, this is Y. According to world, which vectors are looking in positive Y direction and which vectors are looking in negative Y direction, right? So I can just ask, is the Y coordinate larger than 0? Well, //0. That's a smaller one. So I'm asking basically, yo, are you a reversed vector or are you looking forward, right? Which side are you looking at according to the 0 axis? And it's going to kind of give me a bunch of yes, no answers here, true, false. And with those, I can use cull pattern tool to actually take the list of vectors and cull them with this true and false pattern. And it removes everything. No, it doesn't. But why doesn't it show up? Oh yeah, that's because I'm stupid. It doesn't show up because vectors are naturally not displayed. So I need to do vector display. There we go. These vectors according to this point. And we can see that it's looking backwards. It's the incorrect direction. So it's actually very, very easy to fix. All I need to do is in the cull P input, the pattern input, I will right click on it and choose invert. And it's basically everything that was true becomes false, everything that was false becomes true. So that means it kind of shows the other side of the vector array. Okay, so we know that our vectors are correct, are rather aiming in the correct direction. And that is indeed going to be our directions. So I'll just connect it like so. Easy. How many vectors were left? 7,804. We'll have 7,804 rays in total. That's good. That's fine. Terminating surface, as I mentioned before, we don't care about it. This is a surface that eats up the vectors. We don't care about that one. But number of bounces we do care about. So I will say for now, let's just do 2 bounces, or rather let's do 1 bounce. That. So basically from this point, let me hide some things. It's a little bit in the way. Yeah, there we go. So from this point, it produces a bunch of rays that hit the wall and the panels and whatnot, and they stop, right? Because it only can do one bounce, right? So let's do 2 bounces. Bam. They go backwards now, right? Until they hit this wall here. Let's do 3 bounces. Now it's getting a little bit crazy, right? So you can see that you can't really see anything, right? When you do it this way. So this is where we will start making an animation of particles rather than animation of lines, because lines are super complex and particles are not. Particles are just points, and everyone likes points. So let's do some particles. I need to remember how to do that. Yep, got it. Oh yeah, and just to make it more pretty, I will do wires, B-rep wireframe for these B-reps. I will say give me a custom preview, and I will change the swatch, color swatch of this custom preview to white. And now I will hide everything here in Rhino, just so that, you know, we end up having like pretty clean graphics here. Okay, let's come back here. I want points on these curves, and the tricky thing is that if I have like, you know, these kind of bouncy curves, right? And I constantly want the point to move along this curve and make a bend, and all of these curves also have like different lengths because they bounce around differently, but I want always all of the points to move by the same amount, right, according to each other. So if one point moves by 1 meter, the other one needs to also move by 1 meter, right? How do we do that? Well, glad you asked. I can say, by the way, the output is here, the curves are here. I can say we will evaluate the length. We will evaluate the length of these rays, right? Like so, and let me hide them. They are super in the way. And I can just say, how do we do this? I can just say, okay, give me the lengths of all of the curves, right? So I get numbers in meters for all of these curves right here, and give me the longest one. So sort list, sort it, and then reverse the output, because it sorts it from smallest to largest, and I want it sorted from largest to smallest. So I reverse the output, and give me with list item, I can extract then the largest length of these kind of sound rays that we have. So it's 14 meters. Okay. And then what I can do is I can take it and I can multiply it by a slider, right? A number between 0 and 1, right? So let's say 0.5000, whatever. This kind of number, 0 and 1. So if it's multiplied by 0, we get 0. If it's multiplied by 1, we get the length of the longest curve, right? Longest ray. If it's multiplied by 5, we have half of the length. I think that will work. Let's try it out. Absolutely doesn't work. Okay, good to know. So one thing that we need to do is under normalized, the last thing is I will just make a toggle, Boolean toggle, plug it in here, and choose it to be false. And now if I take a look, boing, Nice, huh? Okay, so that works. That works. And basically here, then we can have like 5 bounces rather than 3. And we can take a look at a much longer simulation because now we are giving it 5 bounces, right? Okay, we're getting there. We are getting there. So we have our animation, right? Now it's time to actually make it nicer. So I'm going to say, let's color it, right? Or do we first? No. First, we will be patient. This is going to take a little bit of time, depending on what kind of computer you have and what kind of element you have. This might take a long time to calculate. So what? God damn it. Sorry about that. So what I'm going to do is I'll reference all of the panels and all of the elements in the box in here. Set multiple B-reps, and I will go and make some coffee because this will take like 2 minutes, I guess. In my case, in your case, it might be much longer. If it takes more than half an hour, then that means you need to do something's crashing, something's not right. Then you will need to reduce the amount of elements or something like that. But we'll fix that once we get there, right? For now, 2 minutes. I'm gonna go grab some coffee. Right back. We are back. We are back, and this works. Actually, it only took a minute, so that wasn't that bad. Now I will hide everything here. Hide. There we go. And I'll run the simulation just to see what's going to happen. Nothing happens. Why? Because I am not previewing the output. So now I'm previewing the output and I can see just a swarm of things just bouncing around. Oh, you might also have point flavor set to cross, so it's gonna look like that. Bouncing around, doing their thing. Cool. Right, so now we will take this thing right here, and we will create a nice gradient for it. So I will use a gradient tool. Basically what I want is these particles to change their color over time when they are hot at first, and the more particles bounce around and get lost, the colder, let's say, the color is going to become, right? So I'll go from red to blue in this case. I think that's fine. And we just need to figure out how do we color those particles. Well, first of all, I will use what's called the cloud display, point cloud display. I'll just plug these points into the point input here for the cloud display and disable the preview here. Then I will change the size of the points here because they are way too big, right? To something a little bit more reasonable. 0.02 maybe size. Yeah, that's like 2 centimeter sized points right here. Don't remember. What did I use? Oh, I deleted that part. Well, we will adjust it. So 0.02 meters is fine. And then the last one is colors, right? So we need to give these points colors. So right now, if I just plug this in, it won't work, right? Because this doesn't have an output yet, because it doesn't have any input yet. So how does the gradient work? Well, basically it is, you can think of it as a list of numbers, a range of numbers, and it asks you for, okay, what's the start? What number is this color? What number is that color? And then every number that you plug in between those two numbers is going to receive a color for it. So a very quick example would be if my lowest color is 0, or lowest number is 0, right? So red represents 0, and my largest limit is 10. And then if I give it 5 here, it's going to be yellow, right? If I get closer to 10, it becomes blue. If I get closer to 0, it becomes red, right? So we can change it this way. So now how do we automate this? Well, we need to know, first of all, what's the low limit? So what will we consider to be red? Red is hot. Red means we have a lot of particles bouncing around, right? So I will just say, okay, where do we get it from? These vectors, right? These starting vectors from which the particles are going to be emitted is basically how many particles we have at the start. So I'll just measure list length of these vectors, and I'll plug that one into L0 like that, right? So red represents 7,804 in my case. L1 should represent 0 because it becomes blue when there's no particles left, right? So it gets cooled down. And then for the parameter, so basically for the number that should be evaluated, I need to guess, or not guess, but rather calculate how many particles do I have, right? Do I have left? So this is basically the list length of these guys right here after the evaluation. The reason for that is when I run this script and let's say we're near the end, this is going to be orange and it's going to say, yo, I ran out of length of the curve and for most of the curves because I've already reached the end of most of the curves. So I had to delete the element. Or the particle. So most of the outputs that I will see here at the end of the simulation are going to be nulls. That is not good. I want to actually completely remove them. So I will say clean tree, plug that one in here, like that. So, and for the removed nulls, you need to have it as true, and it's by default true. So now I have only 8 particles left at the end of the simulation. So that's pretty damn close to 0. So they're going to be quite blue. And I can just, I think, just measure the list length of them to get the number of how many particles I have at a given time and plug that one into the parameters. And you can see, well, you can't really see. Let's make it a little bit bigger. 4. You can see that now the rest of the particles are blue. So what's happening is when I start the simulation, right, they're red, and as they're bouncing around, some of them get caught, for instance here, in these elements, right? And they bounce around in the elements many times and they get deleted, right? So the first impulse changes the color a little bit. And then as they are bouncing around more and more and more, they change color, right? To indicate that there is less of us. So the more aggressive the panels are in catching the sound waves and bouncing them around inside of the panels, the faster the change in gradient is going to be, right? From red to blue. In my case, it's quite smooth, a smooth transition. That is one thing. Another thing is just straight up changing the color, I guess, changing up the color of the preview, right? So let's take a look at the right-hand side view. And here I have it set to either wireframe or shaded. It doesn't matter. I'll use shaded for this. That seems fine. And actually, I will change one more thing. I don't want these points to be fuzzy as they are right now. I will right-click it. I want it to be blurry points, right? Something like this. So now I will change the size of them back to 0.02. A little bit sharper, a little bit nicer. Okay, so we have this. Let's change the display. So to do this, I want to first get rid of the grid. So I'll type in grid, enter. I'll choose show grid No. Show grid axis? No. Show world axis? No. I just got rid of all of this unnecessary information. Then I will go to display tab here on the right hand side, and where it says background, I will expand this and choose solid color. And for the solid color, I'll use black, like this. Well, you can use any color you want, right? But I will use black. So we have something like this, and let me see, my camera is not in the way. That's good. Now, back in here, back in Rhino or Grasshopper, I can come back to this slider right here. I can move it back to 0, right click on it, animate, choose to animate it, and I can animate this slider in given amount of frames, right? So let's say my frame rate is going to be 30 frames per second, and I want a 10-second animation, so I will have 300 frames, right? So 10 seconds of animation. And I will go to browse. This is where I choose where I'm gonna save it. And I'll just make a new folder here, or oops, sorry, in desktop, I will make a new folder. And can I rename this? Right click, rename, there we go. I will rename this to, I don't know, side view export, something like that. I'll create one more because I know I'll need it. Not here though, delete. In the desktop, I'll create one more folder, and I'll click on it, right click on it, rename, perspective, view export. So I have two folders, perspective view and side view export. This is the side view, so I'll choose this folder right here, hit OK. Have this going. BMP files are fine. The resolution larger, 1080, 1920. That's great. Blah, blah, blah. All of this seems to be okay, and it kind of even shows you a preview of it. That's nice, but I don't really care about that part. I'll just hit OK. Right? Once you hit OK, it's going to move the slider automatically. It's going to generate the frames and save the frames separately. Right? That's what it's doing. So it's saving the frames as a separate file. And while it's doing that, I will run the, in my case, Adobe Premiere Pro. There's many different software packages that you can use to stitch these frames together into an animation. This is the one that I use, but the free one is DaVinci Resolve. DaVinci as in the guy, and Resolve as in Resolve. So you can use that free software to stitch the frames together. There's also, you can even do that in Photoshop or in Blender. That would work as well. I'll just create a new project real fast, call it QQQ, doesn't matter, okay. Right, so it's right now creating the project for me, and also finishing up the final frames of the animation. These guys don't seem to move because they were shot out parallel to the wall, to the front wall, so they're just kind of bouncing back and forth. That indicates echo in this case, a lot of echo. Right, animation saved. Great. Let me open it up here. So I'll just double click here. This is not a tutorial for Premiere Pro, so I'm not gonna kind of go too deep with this. Side view, image sequence, open up. I just need to quickly, oops, that's timecode, that's my bad. Interpret footage, 30. So we're dealing with 30 frames per second, plug that one in, press play, that's what we get, right? So this is how the sound waves will behave inside of your room, and this is at 1/4 of the resolution, so you didn't see that much, but this is the full resolution, and that's how it's gonna look like. Okay, so we have that going. Super. Oh no. Okay, it's alive. I will do the same thing with the perspective view. I'm just trying to stop it now, but it doesn't want to. Please stop. Did you stop? Yes, you stopped. Okay. I'll do the same thing with the perspective view. So here, hide the grid. Show grid no, show the grid axis no, show wall axis no. The display, solid color black. That's good. Perhaps something like this. Ish. Something like this. We'll do the trick. You can do AXO as well if you want to. Maybe AXO will be cool. Nah, perspective is nicer in this case. Let's do perspective. Something like that. Same thing, same procedure. Right click, well, turn it back to 0. Right click, animate, choose the correct folder. That's important. Hit OK. Everything else is kind of saved. Hit OK. It's gonna do the same thing in perspective, and it's going to save every frame as an animation from your simulation. Let's do this. While it's doing it, I'll just talk a little bit. So I kind of already touched upon the fact that if you have a three-dimensional panel and it traps sound waves inside of it, right? That type of panel will eat up the sound quite drastically. That is important to know and to understand, and that's something that you can focus on within your designs. But the most interesting thing for me is directing the sound waves, right? Seeing how the sound waves, as they bounce off from the panel wall, are they bouncing downwards? Are they bouncing upwards? And how do the sound waves behave according to the geometry of the panels? That's the most interesting thing, and that's something that you should experiment with, right? In architecture, we really don't have that many instances where this kind of workflow is considered to be standard, right? So that's something that you should kind of take a look into. This is done. That's perfect. We go back to Premiere, import, double click. We find the perspective view. Choose this one. Okay. Right click, modify. Not time code. I keep clicking on. Oh, I can just go here. Interpret footage, 30 frames per second. Hit OK. And plug that boy in as well. So I have now 2 of them, and I can kind of position them on top of each other. I can, for instance, I can reposition them. And let's say I can scale this one a bit. Wait. Did I just use the same? Oh, crap. Wrong one. This one. That's the perspective one. No, that's not the perspective one. God damn it. Keep messing it up. Wait, where's my perspective one? Is this the perspective one? Did I import the incorrect one? I imported the incorrect one, didn't I? Yes. Wait, that's weird. This is the side view. Why is it doing that? Let's try again. Edit. Or not edit, sorry. Animate. Oh, that was my bad. So here, viewport was set to be right rather than perspective, so it exported the right-hand side view. I wanted the perspective view to be exported, so I'll just go really quickly go to that perspective view export panel. Here, folder, here, delete everything, and re-export. So animate, and this time around, let's do it properly. So viewport, not right-hand side view, but perspective view in this case. Hit OK. And now we wait again. I'm sorry. Well, while we wait, we can kind of mess around here with these panels, or not, I guess, because this got deleted. Re-imported here. Media offline. Are you the correct one then? Yes, you are the correct one. Okay, so this guy right here, I could kind of do some cropping to it. Oh, this is getting slow. Yeah, that's because of this, huh? We need to wait. We need to wait. My computer can't handle 2 programs at the same time. So we will wait. Or maybe we don't. No, we do. We do. Okay, let me stop the recording and we'll continue in just a second. Right, so now when we have this exported and everything is working, we can kind of, as I did before, apply crop. Apply crop to both of these. I probably will need to crop them. Apply the scale. I'll just do 50% for both of these. Move one of them to the side. Wait, that's horizontal, right? Yeah, that's horizontal. So one is located here. The other one is gonna be located here. And actually deal with 66% scale, I think. No, something less, 60. 60% scale seems to work. 60. And then this is where crop will come in. So that's the right-hand side view, or right-hand side crop, like that. That's it. That's all we need to do. Maybe even move this a bit even further to the side. Once we will play, this is what kind of output we get. And it's super laggy, so oh no. My video card doesn't like this. Anyway, you will see it. I will render it out and I'll put it at the end of the video. So go and have fun with these simulations. Hope you enjoyed this tutorial right here. And yeah, see you next time.